live. Let me start the stream with some interesting me. I don't know why I always sing a little bit at the beginning of the stream. I'm gonna turn myself on some Facebook messages and check if they come through. Because it'd be nice if people from Facebook can chat. Need to mute me so that I don't see myself. So it comes from Facebook, but that's not. Oh no, it does. Yeah, it comes through. Hey. Okay. Chat works. I'm actually, I think I'm going to write an essay this morning that I'm going to steal in part from something I've already written and yeah, a little break from what we've been up to for the past few days. We'll see how long it takes me and if I feel like doing more afterwards. I don't know why it refuses to. There we go. Oh, if you do it in 2 bits and it works fine. Woohoo! Sorry. This is serious. So I occasionally write essays. I often check them on Facebook and Twitter. So some of my audience may well have seen some of them. Occasionally write essays on Medium. Someday I'll do a little video essay. I'll just talk about on stream what suggestion algorithms do and why they lead you to kind of lowest common denominator content. Let's just check my stats because it's always fascinating to see my stats. Oh, I published something yesterday. Only 4 people have read it. Published this a while ago, only 3 people have read it. It's weird the things that get reads. These 2 are my big money makers. Although I like, you know, that's a good number of people, but it's still quite a few. It's still not that many people. Let's put on some music to make my incessant typing seem less typey. So, the intention of these, I'd like to do a few of these, there's a few that I've been thinking through recently, is to represent a different way of thinking about some concepts that are hard to get your head around, and in some ways I think we have only in part got our head around them. Oh, family tells me I have. What kind of writing do I have? Confident and sad. Oh, fine. Yeah, probably. These are not Zephyr's theory of everything posts. They're certainly not intended to be. They're not supposed to be subverting expectations at all. Just saying, what can we take that we know to be true and look at it in a different light, and thus maybe understand it differently. And it's partly growing out of an answer to a question I gave on Quora, which is not the best place to go looking for questions. There we go. Full of clever people, but also based on a recommendation algorithm, so lowest common denominator stuff rises to the top. Let's put this at the very end. Absolutely refuse to do that. In fact, the whole thing's going to be lowercase, so no one can even talk to me about it. And I can't spell argument. Gonna steal a frame from a video I did. Let's just watch this on stream. I really like this video, I showed quite a lot. This was a part of a 48-hour science film festival I did in New York. And you thought my face was big on that little camera. I'm gonna tell you a story. It's a very important story. It's about gravity, and about one particular day. Imagine you're playing a game of catch. The light on that shot has always annoyed me. It's just, the light here is lovely. And then it, like, I think probably the light just changed, but filming is hard. So I didn't really know this before I started this thing. This was, the scientist was paired with a filmmaker, and the poor filmmakers had to try and make sense of what the scientists wanted, and vice versa.
You're playing.
Shout out to Steve Gong, who was a real joy to work with. So Steve, that is me.
Pulled downwards, slowing, reaching an apex, and accelerating back to Earth. Gravity acts out its mischief unimpeded.
This was the roof of the astrophysics department in Columbia, and went up there at like 2 in the morning, and it was freezing. This was October, but New York can be cold in October.
If something is moving fast enough, faster than gravity can pull it back, it can escape. But it'd still always be slowing down, feeling an earthward tug. And life continues like this, day to day, for all time. Until this day. This day, there's another force, pushing objects apart, undoing all of gravity's good work. We don't know what the force is, where it comes from, why it's happening, but it's there. And as it comes to dominate over gravity, everything begins to fly apart.
I can't remember why I was. Hey, Kiev, I'm doing well. I'm watching an old film of mine. I'm gonna steal some frames for a essay I'm writing. I'm trying to remember why I thought this shot was such a good idea. I think I just wanted to smash a lot of plates. Because it doesn't really help what we're doing here. Apart from the sort of gravity running in backwards. It is kind of lovely watching these. Like, it's somehow much more visible, the movement of all the pieces of porcelain.
Of course, we know that this doesn't happen on Earth, or even in the solar system, where gravity binds things together strongly.
We also had a 3D printer, so we played with it a lot.
Then, on the scale of galaxies, something different happens. We observe something very, very strange.
I think I still have these somewhere. I like them a lot. This is the old dome, which has a moving floor, which is what you're seeing there.
Around us are moving away from us. The further they are, the faster they're moving. The universe is expanding, but it's not expanding how we expect. All matter begins at a point, the Big Bang, and depending on its speed, it should follow one of two paths. Either it starts to expand, slows down, slows.
I think this is always true of creators, but they see something like this and they're like, I can't not look at my arm hair. Yeah, of course you can ask a question. We're not doing anything particularly important. What's on your mind? The slight delay between chat and me. We'll keep watching while I wait for a response.
Reverses and collapses. Or, if it's moving faster, it slows, but not as rapidly as it disperses. Gravity isn't strong enough to pull it back together. But this isn't what we see. We see the galaxies far from us start to slow, but then something incredible happens. They start to speed up again, and they fly up.
That is a great question, which I'm going to answer at the end of this video with a few plots.
Faster and faster, pushed by some unknown force of nature, dark energy. The further away two galaxies, the faster they disperse. And light, at a definite speed can pass between them when they're moving slowly. But if they're expanding faster than the speed of light, nothing, no signal or spaceship, can traverse the gulf between them. There is a finite edge to the part of the universe that we can see or travel to, and it is shrinking. One by one, the furthest galaxies disappear off this event horizon, until we are left, all alone, in empty space.
Also didn't shave this. Let me show you a plot which helped me understand this. I think this is the one I want. Come on, just give me the thing. There we go. So firstly, just to respond to the question that you kind of put in there, that there's too many variables in thinking about human behaviour. This is definitely both true and, in that confusing way, that science sometimes works not so true. Because yes, thinking about the behaviour of a single human being is basically impossible to do in any predictive framework. Like, there's way too much randomness, there's way too much chaos, basically. If anyone tries to say scientifically this human will do this, raise an eyebrow at least. But for large enough populations, what is the kind of fickleness of chance can turn into a understandable distribution. That kind of depends on how much the population might diverge. In some things, sometimes individuals are important. And in systems where individuals are important, chaos reigns. In systems where the population is important, sometimes the population can have solid behaviour. And I'm not going to talk about it in too much detail here, but this is one of the most beautiful representations of this. This is what happens when you apply a rule that's almost random to a single particle and then apply it to an almost uncountably large number of particles, and they have this very well characterised, really clean distribution. And in fact, if I look at some images, is it going to give me any? If you do a simulation, for example, of yeah, that's a start. In fact, I would love a GIF of this. If you do a simulation of particles bouncing around in a box, they'll eventually settle onto this. I love, it's relatively, it's kind of university level, but with some work, kind of anyone could get into it. I really enjoy this book, Concepts in Thermal Physics. It's not actually a book that was directly in my courses, but it was one beloved by my advisors. I've got a copy somewhere, I think probably stuck in my office now. It goes through this in a lovely, quite mathematical way, and builds up, kind of starts at the very immediate about the thermodynamic limit, which is this limit where there's enough particles that the bulk behaviour is actually well characterised by a single number. So this weird thing of like, you could put a number on an individual, you couldn't put a number on 2 people, but you could put a number on 1,000,000 people, because actually, eventually, it becomes a distribution. So this is a great place to start, and but kind of by a different way of looking at it. I've been at about midday every day going through some videos by a YouTube channel called Primer, which is a channel about mathematical biology of evolution. And there is a lot on YouTube of good places to learn this kind of thing. I also recommend 3 blue, 1 brown, almost always. uh, which I don't know if there's something that will directly learn this, but it's a great place to start. One thing you don't need to do, you absolutely don't need to have an encyclopedic knowledge of a ton of distributions. That's a really old-fashioned way of teaching these. Some sources will kind of try and teach you these. Much more important is understanding how you would generate a distribution. And like, I come across new distributions all the time because looking at new systems all the time, but a lot of the time the fundamental way in which the distributions arise is similar. Now, I was going to talk about the herd immunity strategy. This is as good a point as any to put the kind of standard caveat. I'm a mathematician and a physicist. I'm not an epidemiologist. This is my reading of this, and it is. I'm going to correct it anytime I find myself being wrong, but even so, be critical about everything. The graph that really helped me make sense of herd immunity is this one. And I think herd immunity is maybe a bad name for it, and I think misinformation is popping about in many places. This is basically the source from which the government changed their from which the UK government changed their approach to coronavirus. So this was kind of linked to in a bunch of news stories. There's a nasty habit of news stories will often not actually link directly to a study because they'll be like, it's too complicated, but they will normally tell you like where it can be found and you can go and look for it. And like this was basically a paper put out by a team at Imperial. They're not the only team, but they're a relatively good one. And if you just Google Imperial COVID-19 or Imperial coronavirus, you should find it. Part of how I find these things is because my social network is filled with other people doing this kind of things. There's reasons why they don't link it. They're worrying reasons. They're partially search engine optimization and partially content moderation. But yeah, it is not the standard in modern journalism to use the same kind of source-based citation tactic as it is in modern science. And that's a shame, although one of the reasons for that is to reduce the complexity of journalism such that you don't need to be a very knowledgeable scientist to understand what's going on in a piece of journalism. So let's get the whole thing on screen so that the caption is here for anyone who wants it, which also means getting my head out of the way. So this is a figure of the number of beds that will be occupied per 100,000 in a population. This is very Britain-centric. Imperial is University of London. But there's little that is very country-specific on here. I'll kind of point them out as we go through. And it's comparing 3 different cases, and slightly confusingly, this isn't a case, this red line. This is the same graph, it's just zoomed in at the bottom. This red line is the critical care beds in the UK. And what you'll see if you have a look at this is that if we start with the do nothing case, so do nothing is we just let exponential growth go. And it grows pretty quickly, and by mid-June, that's kind of about half the country has got the disease, and so the spread rate slows. But obviously at the same time, the number of beds occupied is just huge compared to what we have the capacity to deal with. Like, this is 30 times more than we have beds, and that would be a disaster. Now let's leave the yellow curve for a second and talk about the green curve. The green curve is basically as full a shutdown as you can do in a non-authoritarian state. Close schools, universities, tell anyone with the virus to isolate, and tell everyone to social distance as much as possible. Um, and what we get is that in the short term, wonderful, we stay beneath the bed capacity. And pretty quickly, it has some effects. And the population of the virus starts dying away. But even by winter, there is still quite a lot in the population. There is a case for every 1,000 people, but viruses spread much more effectively over the winter months. And so in this situation, we've stopped doing these measures in like late September, partly because everyone wants to return to normal life as soon as possible, and so in winter you get this huge spike that's about as big as the original. In fact, it's actually a faster spike. There's less people in it. It's thinner, but it's as tall, and that's because in this case there are actually cases all around the country. Like 1 in 1,000 people have it, but they're pretty much isotropically distributed now. And so as it gets colder, the spread rate goes up because people are inside more. People are just more snotty. Like, not to be gross, but I cycle to and from work all the time. That's like how I get to and from work. And I arrive and I'm like, wow, that's a lot of snot. My dad recently gave me some cycling gloves with a little like flannel patch here and here, and I was like, "Is that what I think it is?" And he was like, "It's for what you think it is." And I was like, "Oh, I'm glad that snotty cyclists is enough of a thing that that some company making cycle gloves has directly given me a thing to deal with it." So yeah, there's a possibility that we do these things and then there is a huge peak in winter. Now, that is hard to say with any certainty. Like, that is getting to the point where like the conditionals are many steps down the line. Depends on what the case rate is at this point, which is very delicate, very hard to predict. It also depends on have we made much progress with cures, or at least useful medicine, which actually I've been looking at some of the data on that, and it's quite hopeful that we might. But in the worst case, what we effectively do is we move the problem to winter. Yes. Okay. Now let's finally look at this yellow case, or orange case. The orange case is kind of half-ish measures. So we do the case isolation, we do the quarantine, we practice social distancing, but we don't close institutions. And it's hard to see what's going on this graph, although you see one salient feature, which is that the highest peak is much less. I'm going to read what you wrote in a second, I just want to get through this point. But if we look at the next few months, like, we could ask actually, why is that peak much less? And the reason is that over the next few months, it's close to bed capacity, basically for the whole period until winter hits and the spread rate flies up. So we've worked through more of the population. We've got some, and this is what people mean when they say herd immunity. So I think the tactic, and I couldn't condone or decry it with much authority, but I think one way to visualize this tactic is that it's in our interest to stay as close to this line as we can, this red line. This orange tactic does go over it, but then that also uh, that depends on like changes that can be made day on day, and at some point with this tactic, the spread rate is kind of constant. Like if there is a week where too many people pick up the virus, restrictions can be made stricter, and if there's a week where the beds are slightly emptying out, restrictions can be lessened. It allows sort of balancing out tactic where it's kind of there is a too far. They'll constantly be tiptoeing up to this red line and never wanting to go over for it. But there is a real advantage to tiptoeing up to it. Which is just that by the time it gets to the highest spread rate period, the number of cases has been reduced by a factor of about 2. So this is what I've come to understand by the herd immunity tactic. There is probably a whole other discussion to be had about what like general public and politicians and also epidemiologists and other scientists have come to understand about herd immunity tactic. But this meant a lot to me because for a few days I've been like, why aren't they closing schools in Britain? And I looked at this and I was like, oh, yeah, that actually makes a lot of sense. And so yeah, I can see the point of the strategy. So let's have a look at some of the things you've written. I'm gonna work backwards. I'm gonna look at your most recent things first. Does the herd immunity strategy give the virus more chance to mutate? It probably does. I have no idea how to estimate that likelihood or the likelihood of that mutation being dangerous. Something worse than something worse than this virus in some ways was SARS-2. No, scratch all of that. That's completely wrong. I'm going to say it in a different way. Something that I found out yesterday is that this virus is 90-ish% genetically similar to SARS-2. It has relatively similar to SARS, to the original SARS. In fact, this virus, one of the more sensible official names for it is nCoV SARS-2. And we could, I don't think we will, I think it's too late now to change what we call it, but SARS-2 would not be a bad name to be calling this. It has different properties. It's less deadly, it's quicker spreading. And there's a whole family of viruses that have mutated kind of in that SARS-ish family, and there is always the capacity for more mutation. I think maybe we should expect, this is absolutely conjecture now, I think maybe we should expect this virus to be an addition to the flu 10 years from now, to be another flu that goes around that is that we're able to reduce the harm of, but we're never able to get rid of entirely. Yeah. I don't know what stuff like pathogenic level 4 means. Kudos to you if you do. Watch out that you're not doing something that I see a lot of people do, which is I hope you won't mind like me accusing you of potentially doing this, of finding a name for something, mapping that name, like finding a piece of nomenclature, mapping that nomenclature to what you believe, and then believing that you having found that name has confirmed your hypothesis. Everybody does this sometimes. So, you left some long comments and I'm going to have a look at them now. Time span will take longer than 2 weeks. You use very strong emotional language here, which makes me think you're probably feeling a lot of anxiety about what's happening. Things like complete economic implosion. this virus is mild in most people of working age and very mild in children. It sends some fraction of people to intensive care and they recover in weeks. The workforce is not about to disappear. The capacity to make the economy function is not about to disappear. We've kind of already seen the economic hits. Like, it might keep getting worse, but basically there was a period where the markets weren't reacting to the fact that this was happening, and then it kind of clicked, and you saw over a day a huge drop in the markets, which was basically people costing out how much this might cost. And those estimates will change, but probably by a factor of 2 or so. You think growth in China will restart again? Yeah, I think it probably will. I think all countries will probably be footing this curve in one way or the other. Gonna look at some of the things that you've sent. So these are on medRxiv. Where are these people from? I don't know vids. I don't know the University of Melbourne particularly. Where can I see it? Sorry, I've been up in the chat, I haven't been seeing. Got a test on this in college. Peer review does not make something not dubious. And because something has been peer reviewed does not mean that it is not dubious. It's an okay first telltale of whether something is dubious or not. And to really understand if something is a worthwhile piece of work, is work in itself, I recommend going and looking at the other work that people in these groups have done. I recommend seeing the breadth of their catalogue, seeing if they have a good number of citations, seeing if their citations appear in journals you know. It's not bad to link it back to journals you know always, although they're a strange ecosystem. If something is 2 degrees of separation away from nature or science, it's more likely to be something that the community seem as plausible. It doesn't mean it's right. Peer review absolutely does not make something right. Peer review is basically does it meet some, or does it fail to meet any quality standards? It's is there any reason we should exclude this paper from being published? Not, is this paper a very good paper? Peer review does not make papers better, and it doesn't make them right. It just looks for any obvious reasons why they are wrong. And so if they can't find any, the paper would tend to get through peer review. Ooh. I think I'm now truly beyond my pay grade in trying to read this. But I have no idea what stuff like this means. Hey, you sent me a Wikipedia article instead. Much more my speed. Biosafety level. So this is a very physicist thing to say, but I think I've got it written on my board behind me. There are 2 times where classifications are meaningful. Either something has a phase transition or is a clean overdensity. By a phase transition, I mean that the system actually changes its behaviour as you go past the point on which you're classifying. So ice to water, they're different materials. They do very different things. Like if someone's like, "Help! My house is filling with water," and you turn up and the house is filling with ice, you're like, "Well, I didn't bring the tools for this. You told me about the wrong thing." Over densities and under densities are more subtle, but basically like let's say there's two groups of things that we could name, and there's not very much in between those things. Levels like this, I am always very suspicious of. I'm sure that they're used well by people who know much better, like what's going on here, but I would guess that there's no actual like mathematical meaningfulness to the value of this number. It is just something to denote, to quickly get at a certain level of severity. And what that often means for classifications that are not at phase transitions is that two things which have different different names can actually share behaviours, and two things which have the same name can differ in behaviour. That's a pragmatic classification. Classification just because you need to write something that everyone will recognise on the front of the box makes really good sense. I think I'll read this another time rather than doing it on stream live. Also, I'm going to drop into my some people in my department do a daily coffee time, which I might go join. I'm glad you're enjoying this and learning from it. I hope it doesn't feel like I'm kind of shooting down at all, because I feel like I am a little bit. Mostly just being like, slow it down, look for where your response is emotional or where you're putting together a lot of facts to make a complex argument. Because complex arguments, you can always make one, but you can't turn a complex argument back into a simple argument. You can turn a simple argument into a complex argument, that is easy. Just introduce more variables. But a complex argument is kind of, you can't really hold it in your head. And that's a lot of what science is at high levels. It's managing to actually hold enough of it in your head that you've got the tools to hand so that you can actually work with them. The same with any kind of mastery. Like you watch someone who's really good at playing a video game and they've just got all the rules in their head such that it doesn't take them any time to think about it. Like if you watch, and I don't know how to, but I occasionally try to, something like high level StarCraft, when a expert player sees a Zergling in the 42nd second, they're like, I know what this means. These are one of the two things I can do about it. I can act on this. They have the whole picture in their head, basically. And that requires making things more simple. That's why I'm writing this essay today. It's a way to potentially make things more simple such that it's easier to get in your head, it requires less cognitive work to get it in your head, and sorry, I got distracted by your comment. Do I think you could become a scientist on a biochemistry level? Yeah. Absolutely. If that's something you want to do and you're willing to put the work in, yeah. No one is a scientist because they're kind of magically fated to be it. They're all the scientists because they put the work in. Science isn't that. Science doesn't need. Firstly, I have very little faith in a concept of intelligence. But science doesn't even really need intelligence. It needs hard work, and anyone can do that. Some people especially if they're passionate about a thing, are even better at it. Um, there's no way in which you have to deserve being a scientist. And the language you use there, maybe I'm reading a little bit too much into it, but it feels a bit like you're asking, like, do I deserve to be a scientist? Can I be one of the special chosen few who are a scientist? And that's a picture of science I think is still in the media, that scientists are kind of honestly, it's a really fascist picture. That scientists are rare, singular people, but no, scientists are people who enjoyed a thing enough that they didn't feel like putting the work into it was that much of a cost, that they were able to take on the risk of going through higher education. There are some like lower limits of performance that they had to get through. Another day I'll talk about why I think those lower limits themselves might be problematic. I think a lot of people who went through scientific education to a high level, like I did, to kind of like graduate level and the research level, kind of had this thing of like, okay, but when do I become a scientist? And it takes a while to realise that such a thing doesn't exist. You never become a scientist. If your teachers are encouraging you to go into academia, that's about as good a sign as any. Reasoning is not a thing that you magically have. I don't think any cognitive ability is a thing that you magically have. These are all things you learn and can change and can grow as skills. If you're looking for ways to test and grow those skills, well, it's actually a hard question, but like, you're never going to be deficient in reasoning to become a scientist. You're never going to be deficient in mathematical ability to become a scientist. Some of these things might be harder for some people than others, and will take more work and make it an uphill struggle for some people. But anyone can do it. It's just, can you do the work? And if you can't do the work, that's not because you're bad. Like, sometimes I don't know if I'm going to be able to be a practicing, like, professor level scientist, because sometimes I'm not high functioning enough. It's hard to tell, but I would recommend. There's a lot of different, like, I don't know. I'm tempted to recommend some things. I'm worried that they might be flippant. Also, I'm always worried to recommend anything that costs money. Firstly, I would recommend doing your best to detach yourself from the kind of liberal media picture of what a scientist is. Like, if you ever watch a film where there's a scientist, where they need the scientist to solve a thing, that looks nothing like science. Science is done by many people, often without real knowledge of the direction. They're just working on the problems that are interesting to them. Equally, if you do see a film as scientists portrayed like that, are you Google translating everything? How does it come out? Because I speak weirdly, so. In which comments do I think you could have improved your reasoning? I probably shouldn't pretend to be a coach of great reasoning. I'm trying to work on my reasoning all the time. One of the biggest things is relativism. Always relativism. If you and just looking out for places where you assume that you've thought something through, but actually you've inherited the knowledge. This is really common. We think that something is come from our own thoughts, but it isn't. It's kind of osmosis in, and thus it actually forms a really shaky groundwork for uh, for whatever we try and then do next. And relativism is hard to put together with a lot of the classic views of scientists. I really struggle with this. I went into science wanting to be a determinist, and I still want to be a determinist, but I absolutely can't. I wanted it because it was clean, it was neat. Relativism can be really uncomfortable because you want to know for the things for certain, and relativism tells you well you can't. Even things as simple as like, am I one of the good guys? Is my reasoning good enough? Can I become a scientist? None of these things have yes or no answers. They have a well, given these conditions, the chances are this, and or even a well, possibly, but we can't even know the probability. Something like that book I recommended, Blundell and Blundell. It will show you a mathematical world that both isn't our world but is really useful as a comparison point to our world. So a lot of the use for that kind of hard theoretical mathematics is being like, well, when isn't it true? And it's true a lot of the time, and it's not true some of the time. And the times where it's not true aren't not science. And equally for the times where it's true aren't when it's not science. Like, it's an interplay where sometimes things that need structure, sometimes they don't. I'm basically rambling. The thing I was going to recommend, I don't know at all if it actually will help, but to me, it's one of the things that most captured some of my experience of actually working through problems as a practicing scientist, is a game called The Witness. I think you can learn a lot about how you think playing this game, and I think starting to think about how you yourself think is one of the first steps for trying to encourage yourself to better patterns of thought where you're maybe more susceptible for acknowledging and learning from your own mistakes, patterns of thought where you are honestly, like, a lot of it is just learning that it's okay to be wrong, which is something that you're kind of taught out of habit by schooling. You absolutely should be wrong all the time. I try my best to be wrong every day. If I'm wrong every day, I tend to have learned something every day. That's unpopular, even in science. Like, there's some people around me who, if I told them, oh yeah, I'm wrong all the time, they'd be like, oh, so you aren't a good scientist then. But yeah, that's maybe a good place to start. I'm actually going to end the stream here because I'm going to go join this group chat. I will probably be back after that, and I'll see you then. I hope that helped. Just